Alright everyone, welcome to my final circuit for the SparkFun Inventors Kit, circuit number 5C, the autonomous robot. Just going to pop up the IDE so my serial monitor is nice and clear for you guys, just to show kind of how it works. So I will be showing a video of the robot action functionality in person, but I just wanted to do this to show you that the serial monitor and kind of the logic of the robot. So I did change a few things. I mean, obviously from circuit 5B, you know that I altered the motor's orientation to my physical prototype, but I did slow down the speed a little bit to, I think it was 150 off the top of my head, because I found it was going at 255, it was going way too fast and hitting the walls. But so I made it more of a crawl speed, and then I kind of altered the backup and turn logic because I was trying to go where it would kind of choose left and right, but then I realized with one sensor it kind of makes it complicated. But let's get into it. So we'll flip the switch on. I'm just going to pick it up. So as you can see, the wheels are spinning nice and slow because it doesn't detect an object within 10. When I move it closer, it's going to stop the motor, and then we'll do a backup and a spin. And I just see the reversing and turning. So it reverses, then turns, reverses, then turns. But whenever we get going, it'll move forward. So as you can see, one thing I will say is, yeah, your coding's going to take a lot of time. I basically gave it a turn time of, yeah, I was right, 150, and then I had the speed of 100 for the most part. So it'll alternate between 150 and 100 as it approaches a target, with 10 inches as my threshold. Sorry, I'll show you what I'm actually talking about here. Then kind of, yeah, other than that, like, I really struggled with the logic of trying to do it. So I basically just have it do up to 6 right turns and try to make it have it so it's a 45-degree turn each time. Once it doesn't see the object, it'll continue going forward, which, you know, for the most part worked, especially given the slow crawl speed. You'll see it. I was able to do some complicated obstacle avoidance upstairs. I went under my table through the chairs. So hopefully you guys enjoy this circuit. If somebody found a better way to do the program logic, I'm all ears, because this one, yeah, it took me quite a few hours compared to the rest of the course to try to make it work. I do think if I had a sensor on the left and right, maybe even 2 more on angles to give me like that nice 360-degree view, or I was almost going to consider pulling the LiDAR from an old vacuum robot I had that would have spun around and around and constantly get me feedback with a 360-degree view. But I would also need to create a mount higher than the wires, or else it would just constantly be detecting itself. But if anybody has any code suggestions or would like my code, just let me know. And thanks for following my video. Everyone, so I was giving you a demo of my circuit number 5C for Computer Science 444. Just note I did slow the pace of the robot down so you can see it a bit better. But here we go. And yes, my wheels don't align properly, so it kind of drags to the right. If you look closely at the engine, it's not exactly even. I'll just show that it can detect on the fly. So again, this is just an add-on video to what I just showed you with the serial monitor and the actions of the vehicle. But so far, I would say it's a success. I think we're really limited by the sensors. If I could have 3 sensors on this, I think it would be even more beneficial. Just so you'd have your side view and front view. If I could add 2 more tires to the back of the vehicle, it would be good for better controlling and steering. But I would say it's a success. It's not quite as good as my Roomba, but you get the picture. All right, thanks. This is showing that it can do multiple turns until it sees there's nothing going forward. So I missed that in my last little video there. So this is a bit more of a complicated journey that it took, but it'll probably even come out this side out. Oh no, the sensors are pointing up a little bit, so it's detecting. And that's where I was getting at with the, be nice to have a sensor kind of off to the side here. All right. So thanks for watching. Same thing. If you would like the code, just let me know. The code could be a little better. Like I struggled a little bit with trying to work the logic. I wanted it to be autonomous, where it could go left and right, but again, without that second sensor, I found when it was choosing left and right, it would just get stuck more and more often. So, all right, thank you. Everyone, welcome to my Tinkercad simulation of the computer science 444 circuit number 5 seated autonomous robot. So we will start the simulation. We'll close the switch off just to show that it's off. It'll ping this here in a second to say turn the robot on, flip the switch on. So hey, flipping the switch on. We can kind of set this sensor so you know it's clear, clear, clear. When it's under 10, it's going to say stop. Motor stopped, reversing and turning. One thing, I just set the sensor down here, make it nice and easy for everybody to see. And earlier I was having issues when I had it actually plugged in, but it seemed to resolve itself just as I was starting to make this video, which is quite funny because earlier in this course I'd also had issues with this, but now it seems to be working just fine. So there we go. So again, if you'd like my code, just let me know. This is quite messy. I could have added oscilloscope to show the power going through, but we confirmed that in circuit number 5A, so there's no need to redo it. Really, the only thing I had to do here for wiring was add the object sensor here, and then we were good to go. So hopefully you enjoyed my video for my final circuit. I will be updating and pitching my project to the professor later today. So hopefully I have one more night's video for you guys for this course. So thank you very much.